And we should be live. Welcome everybody to another live stream repair. We've got 5 HomePods sent in to us today with the full suite of issues ranging from no power to death farts to just straight up no bass. So let's go ahead and crack right on into these. Go ahead and open up our first one here from Alex with no power. There we go. Okay, let's set the box to the side. And here we've got our pod. Before we get started, of course, let's get ourselves a beverage. All right, we can begin. So, no power, huh? Let's go ahead and plug some power in and see that. We've got no power at all, yes indeed. And according to our kilowatt meter here, we're pulling about 6 watts from the wall. So I've said this a few times in past live streams, but basically based on the power draw, I can take a pretty good guess as to what's failed in there. No power draw is usually a blown fuse. 1 to 2 watts is usually a shorted capacitor on the logic board. And then 3 to 7 watts is a shorted diode on the amplifier, which is of course the most common failure mode for these no power scenarios. Let's crack on into it and see what's going on from the inside. This one's being sticky. Oh, beautiful. Let's get these screws out for the display. And then we can pry that out. We're just using the metal tool to create a gap for our plastic tool. That's what we're going to actually use to pry this up. You can use a metal tool if you absolutely need to, but be careful because you'll scratch up the display PCB. You can potentially damage it. Let's see. That came up all right. Not the best, not the worst. Hey Alex, welcome to the stream. I'm glad you could join us. Hey Cameron, how's it hanging? We're just going to stick this adhesive back down here before we continue. I'd rather deal with it now than when I'm putting it back together. go. Then we can get this frame out. Oh, don't want to forget the drawstring screws. I put the screwdriver down every single time before getting these. One day I'll remember. Get that ribbon cable detached there before we start the pry. It is time to pry. Seems to be coming up all right. Let's see if that'll come up the rest of the way by hand here. Oh, so close. Hey. Yeah. Easy peasy. Subwoofer time. Let's get our lights on here. I was wondering why I felt a little dark over here. There we go. All right, voice coil in the subwoofer looks good. Feels good. Smells good. That is a happy subwoofer. Can you please show on which settings you measure death farts? Yeah, I can absolutely show ya. Sounding like you were trying to become a Super Saiyan. I love it. Oh, you little bugger. That's what I thought. You cannot beat the ES15 motion control electric screwdriver. All right, the main attraction, folks, the amplifier board. Just doing a quick visual inspection to see that there's nothing obviously damaged here. Everything looks great. Our diode here has a date code of 1748K on there. Who wants to bet that that is shorted out and causing our problems here? Yes, sirree. That diode is shorted. Let's get that replaced with another one. And pop goes the diode. out of here. Who you calling busted, Buster? That's the idea, Alex. We've been doing no power repairs for about a year now, and no one's had to come back for the same issue yet. Which is great news for everyone, of course, but me too, and kind of makes me believe more that it was just a bad batch of them. But this is the same spec, it's just a much newer run than what they originally used. But I give all of my repairs a 6+ month warranty. Basically what that means is for the first 6 months, if any of my parts or labor fails on ya, I'll cover shipping and repairs both ways. After 6 months, up to, I haven't quite decided yet, at least a year for sure, but I don't know if 2 years is kind of pushing it. But at least for the year following repairs, if anything happens, I'll cover repairs if you cover shipping. So, that's of course excluding software issues, but haven't needed to do that for anyone yet, so. I've said it a lot before, but we don't really know for certain what causes these diodes to fail. All we've got is just the sheer number of diodes with a specific 2 different date codes that are failing, and then we've got all these diodes that are older or newer than those that are all still working fine. We replace the diode in every single HomePod repair regardless of what it's in for, just out of precaution. But based on the sort of uncertainty, I try to make the warranty as reasonable as possible. Let's see what we've got here. Got our power supply put on. We've got the ribbon cable for the logic board, which we'll hook up in a sec. Here's our subwoofer. We've got a power connector that we ripped out of another HomePod that we can connect to the power supply, which will allow us to plug the HomePod power cable into our amp and power everything up. Let's grab our logic board, which is already attached to a display here. And then we will see if this powers up. No smoke. Very nice. Alright, so while that's booting up, we're going to go ahead and hook up our multimeter to the subwoofer here. so that we can check this amplifier for any DC offset. And really quick, DC offset is simply just how far off from 0 volts DC you are. So when I say there's like 50 millivolts of DC offset or 500 millivolts of DC offset, or God forbid 3 to 5 volts of DC offset, that's just simply saying positive or negative. It doesn't matter. At the end of the day, any DC voltage on your woofer is unwanted DC voltage, be it positive or negative. So to make my testing and repairs a little easier on here, I've actually got alligator clips soldered directly into my subwoofer already. If you were doing this by yourself, you would just take your positive and negative probes and connect them to each of the pads on the side of the subwoofer here. They actually make it kind of easy for you to test it with the exposed wires on the side of the subwoofer. So you just stick each probe to each wire, and you can measure your DC voltage going into the subwoofer. On my cheapo multimeter here, there's a specific DC voltage mode, and there's a few different options under DC measurements. So there's 200M, 220, 200, and 1000. Those are basically just the different scales. And basically you want to pick the lowest scale that's within the range of the thing that you're trying to measure, because that's going to give you the highest accuracy, or the highest, the most, yeah, exactly, the highest accuracy for measuring what you're trying to measure here. Generally, we expect to see the DC offset no more than around 50 millivolts out of the amplifier. So we're going to stick our multimeter into the 200M mode, which basically just means 200 millivolts. If the multimeter reads, or if there's more than 200 millivolts of DC voltage coming into this woofer, and we've got our multimeter connected to that, and our multimeter is set to 200M mode, then it's just going to read 1, basically saying overload. So then we would need to jump up to the next scale, which is 2 volts. So that'll allow us to read anything up to 2 volts at the cost of less resolution in the millivolt range, if that makes any sense. So we're going to start in the 200 millivolt range, connect our multimeter to our subwoofer here, and we just want to make sure that the amplifier is not in standby mode. So standby mode is just this low power mode that your HomePod will go into after 10 minutes of inactivity, or when you first plug it in and power it on. When it first boots up, it's not going to be in active mode. It's going to be in low power standby mode. So once you plug your HomePod in and get it powered up, you'll need to do something in order to activate it again. I just like to tap and hold the top. And we can see here we've got 5 millivolts roundabouts of DC offset. And the fact that it's staying relatively steady at around 4 to 5 millivolts, it's not growing at a fast pace towards or past 50 millivolts, that tells me that this board is looking pretty good. And we don't need to worry about replacing any of the filtering capacitors, or those no signs, at least here, that those are starting to go bad. So we can unplug all of our test parts from this and put it all the way back together now. That is a happy and ready to go amplifier board. All right, here's the shell. Let's get the amplifier in. Are you using wireless ESD protection? Yes, it's the latest and greatest. I do have some stuff around the desk that I touch on occasion to discharge myself, de-zappify. I've got a like an ESD wrist strap and a whole desk mat and all that, but I basically have to, of course, tear down the whole setup to get it on there. Some nice Gamers Nexus stuff. Are the capacitors pretty low voltage where you didn't need to really discharge before reassembly again? To be honest with you, I couldn't tell you. I will say, so these are 63 volt 1000 microfarad, and this is a 25 volt 1500 microfarad. Especially right after we've just powered it on and putting it back in here. I don't know. I don't really like the idea of discharging them every time. They seem to generally discharge themselves pretty rapidly after being unplugged from power. Would be a nice experiment to time it and see how long that actually takes. I've got some amplifier boards, like parts boards, that we can definitely try that with, actually. I do not think, I don't think I have an insulated screwdriver, though. That's my problem. I love how YouTube held this message for review. That's okay, YouTube. Thank you for trying. Time for that power supply. Yeah, no kidding. The real kicker is the warranty replacements, the out-of-warranty replacements that Apple still charges people upwards of $300 for to this day are still from the same original manufacturing run. So, like, people are still buying those. I can't remember if it was yesterday's stream or the day before, but a HomePod that we had taken apart was it was missing something. Was it just a whole screw? I think. Oh no! It was a grommet that covers the screw for the top basket. Yeah, one of these was just absent. So lackluster quality control, to say the least. Oh yeah. Cannot deny it. It sounds like there are still like large commercial and enterprise customers that have dozens, if not hundreds, of these deployed, and Apple is still fairly intent on supporting them for quite a long time. It will be interesting to see exactly how long they take it, though, because the iPhone 6 doesn't have support anymore, right? For the latest version of iOS? I can't remember exactly. But if that's the case, then technically the hardware in this, the CPU in this, is the same as that, and they still support this. So, you would think, once they stop supporting the iPhone 6, then support for the HomePod would be soon to follow. If not at the same time. Yet here we are. Thoughts on a new HomePod being released? I've given some answers in a few past live streams, but basically, I would love to see a new full-sized HomePod that's basically physically the same, but with upgraded internals, cosmetically identical too, because then most likely they would add it to their self-repair program, and then people could buy parts to not only repair their existing new generation HomePod, but perhaps do some sort of upgrades or repairs for their older ones too. That would just be the perfect world, though. And I think we are far from that ever happening. What kind of updated internals would you want? I would like to see just more robust filtering and audio amplifying. Because like we've seen a few of the amp chips blow up. We've seen the filtering capacitors time and time again fail and cause no bass or death farts, frying subwoofers left and right. I would be 100% happy with the essentially same exact hardware design in and out as the original HomePod, but as I said, with a more robust and just the things that are problems in the OG fixed, like the no power, bad filtering capacitors, and perhaps a newer CPU, obviously, so that way we would have software support for a long time. Sounds like the neighbor is blowing their leaves into my yard again. I'll share a photo in my community posts soon here showing the absolute unit of a pile of leaves that he's been piling up on my side of the fence, blowing the leaves in his yard into mine. Never thought that would happen to me, but here we are. Oh yeah, John has the right idea. Give me Matter support. Give me Wi-Fi 6 support. It would be... honestly, I could care less if they kept it AirPlay only. It would be nice if they had auxiliary in. I could care less if it supported Bluetooth. I'm totally fine without having Bluetooth support. I have a hell-bent hatred with Bluetooth. It's never been a great experience for me. AirPlay, on the other hand, has generally been better for me. Bluetooth, though, ugh. And I couldn't imagine listening to Bluetooth quality audio throughout my house all at the same time. I just don't know how good that would sound, and I'd rather not. Rather not for those moments I really care. Sometimes I could care less and I might not notice. $349 at launch was crazy. Now hold on a sec, cause the HomePod was estimated to actually cost around $250 for Apple to manufacture per unit. $250 per unit. So when Apple was selling them for $350, that's relative to their other profit margins, that's pretty low. And then remember when they dropped them down to what, $300 on sale sometimes? They're making $50 off each HomePod. But I think the idea was that they were hoping more people would buy them and get sucked into their Apple Music and podcasts and their various audio subscription services. And that's where they would make their money back. Making it AirPlay exclusive and iOS exclusive, or Apple only, and not allowing Android and those kinds of devices to play to them. I think that was their attempted play there. Oh yeah, the Matter support is indeed only for the Mini. The Mini's the only one with the hardware capable of supporting Matter because of the Wi-Fi requirements. But the OG HomePod, unfortunately, does not have what it takes for it. Yeah, the mesh drawstring can, sometimes it plays perfectly nice, and other times it fights with you for 10 minutes. Usually it's one of my more favorite parts of reassembly. Alright, the final piece. Let's get that adhesive nice and soft and sticky again. All right. Woo! Assault. Okay, let's see what we've got. Drum roll, please. Very nice. That is some weird white balance going on there. On that bottom left camera.
I'm having trouble connecting to...
Sounds nice.
I'm having trouble...
Volume buttons light up nice and even. Alright. We got Alex's HomePod fixed up without a problem. Let's put that in the box and set it to the side. And let's get number 2. Let's change our text up on the screen there. Wee. Oh no. So, wow. Okay, here we go. Let's get that opened up here real fast. Let's see. I believe they said theirs started with constant clicking or ticking and ended up with losing its base here. So we're probably going to have a case of some pretty nasty DC offset here, which killed the subwoofer. Yeah, that's a pretty neat packing job you got there. I like it. kind of keyboard are you using? Is that a Lenovo? Ah, it is not a Lenovo, but it is a Tex Yoda. It's my favorite keyboard. It's got Cherry MX Blue switches, solid aluminum case, built-in USB hub, and obviously the mouse, the nipple mouse, my favorite part, with the mouse buttons, and all through one cable. So it's an excellent keyboard to have while I'm working on servers where USB ports are very limited. Works great with bootable flash drives and having just all of that going over a single USB port. And it fits nice on the desk here. Oh, I forgot to mention the name of it, dang it. It is the Tex Yoda. I'll go ahead and type that in the chat. I bought this years ago off Massdrop. I paid like a couple $100 for it, and I still had to put the thing together myself. I don't think they sell this exact one anymore, but I do think they sell newer versions of it. Alright, so no bass. Let's check it out, yeah? See what we've got here. Yeah, this is still my all-time favorite keyboard. I love it. You could definitely use it as a weapon too if necessary.
I'm having trouble connecting to the internet.
Oh, yep. That is certainly a severe lack of subwoofage. I'm gonna bet because they previously had bass and they had loud popping and constant clicking, and then the bass died, that unfortunately the subwoofer's dead in here. In some cases, when you suddenly have no bass and you previously didn't have issues, that by chance could be a different short on the amplifier board causing that. But in most cases, unfortunately, it ends up being the bass speaker. So let's crack this open and see what's going on. Yes. Yes. Oh, I feel it. This one's gonna be a good one. Yeah. Where'd my hooker go? There we go. we can, without taking it apart any further, we can actually do a quick physical test on the subwoofer here to see if it feels smooth when we gently push it straight in and out. If it feels smooth, then likely it's still okay. But if it's feeling nice and scratchy and gross and grody, then most likely that's our problem here. Ooh, yeah. That sounds horrible. Almost sounds like air is getting out too. Like it's not sealing right. Oh, get out of here. I'm just kidding. Don't leave. Time for the pry. Oh yeah. Nice and easy. Can you explain again what you were looking for to determine if the sub itself was okay? Yes, so basically we're just gently pushing the speaker in and out, and we're feeling as we push it in. If it's moving nice and smooth, there shouldn't be any like grittiness or texture to it. You shouldn't feel anything basically. But if you feel like it's like scratchy or gritty, not actuating smooth, or just straight up, yeah, like that, just straight up like locking up like that, if you listen too, sounds nice and crappy too. You'll get a clearer idea once we get the subwoofer actually out though. And you'll almost certainly smell it too, if you're doing this yourself. And we'll grab a good subwoofer to compare to so you guys can hear the difference. And this is just a symptom of the root problem. This isn't the only thing we're going to be fixing here. Oh, that smells. Not sure if you hear that, but the voice coil in there looks toasted. So this nice copper color is what you want your voice coil to look like, and that charred bit there is basically what theirs looks like in there. Do I dare smell it? Ugh. It smells like burnt electronics. Burnt electronics are a very distinct smell. If you know, you know. But it's hard to describe what it smells like because it's just its own smell. Go microwave a motherboard and give it a whiff. Then you'll know. Don't actually do that. right. Now, here is the source of the reason why that bass speaker blew up. The amplifier. Before we do anything to this, we're going to go ahead and power it up and get a subwoofer connected with our multimeter here, and we will double check what we think killed the subwoofer to be caused by those failing filtering capacitors, just allowing too much of that DC voltage through, just absolutely roasting that woofer. Who wants to take any guesses how much DC offset this thing is spitting out? The resistor right here next to the subwoofer connector that loves to blow up looks fine still, so not sure how much we'll actually see here. I'll go ahead and guess 350 on a cold boot, but it'll obviously be growing pretty rapidly too. Alright, no changes, no repairs. We're just checking to see how much DC offset this thing has. Just to confirm our guess here that that's what killed the subwoofer. We don't want to just replace the subwoofer if it goes bad. We want to make sure that there was a reason that it went bad, which is usually too much DC. That DC offset, no. We're going to go ahead and go up from the 200 millivolt scale. We're going to go straight to the 2 volt DC scale on the meter here because I'm fairly positive we've got more than 200 millivolts. Oh, 500 millivolts, and we're already at 550. That's juicy. Oh, look at that pop-dough. Alright. Let's replace the filtering capacitors that are allowing that to happen. Afterwards, if we did it right, we should see less than 50 millivolts going into the subwoofer there. And then we'll put this HomePod back together with a fresh subwoofer, and it'll be ready to go. Oh, and I almost forgot. As I said earlier, with all of our repairs, we're also going to be replacing that 60 volt 5 amp Schottky barrier diode that just loves to fail and short out and cause the most common issue that HomePods come in for, that being no power. So regardless of what your HomePod comes in for repairs, we are going to replace that diode every time. There's the boys. Let's get a little better focus on that. There we go. Let's pull them off. It's going to be these 4 capacitors right here. It could very well just be that one of them is going bad, but it's hard to test exactly which one that is. Even if these are going bad, they'll test with normal in-spec capacitance, but it could be that under load and heat that they actually fail. So we're just going to go ahead and replace all 4 of these as we do every time. We do not use OEM part. Oh, okay. No, I take that back. For board level repairs, where we're replacing like capacitors and diodes and such, we're using whatever we can get off DigiKey or Mouser. That's a higher, at least higher quality, good reputation manufacturer, that kind of thing. As for the subwoofer, we're going to replace their broken one with another used one that we will pull from another HomePod there. Unfortunately, there's no source in America for brand new ones. We have to pull them out of other HomePods. Well, that's not fun. Where'd the other one go? Here it is. Let's grab some new caps. Flux up the board for some fresh solder. And we're going to use some solder that melts at around 250 degrees Celsius. I think, actually I can't remember what this stuff melts at. We're using low melt solder, so that way we don't have to use as much heat to put these new capacitors in, which should give them the best chance possible for a nice long life. A little more flux. And we're going to turn our heat down to 250. All right, easy peasy. How's that looking? Oh, that's looking very nice. Beautiful. All right. Our diode here has a date code of 1736K on it. A little older than we typically see with ones that fail, but like I said, we're going to get that replaced. Prevent that no power issue from happening. Would help if we turned our heat back up. Get out of here. And there you have it. Fresh filtering capacitors to get rid of that unwanted DC offset. New Schottky barrier diode to prevent the no power issue. Let's get this board cooled off real fast. One thing to keep in mind if you're doing your own repairs and testing here, similar to what we do here, you want to test your DC offset when your board is at room temperature. You don't want to test it immediately after applying a bunch of heat to it, because the hotter your filtering capacitors are, the less effective they are at filtering DC offset, or DC voltage. Just an inherent property with these types of capacitors. So if you immediately go and check for DC offset right after heating your board up and those caps up, you might get a higher number than what you would normally actually get. So, with that all said, let's put some parts on here, power it up, and see if we got rid of that DC offset. All right, what do we got? Oh, and we've got our multimeter set back to the 200 millivolt DC scale there. What do we got? Oh, beautiful. Wonderful. So we are far below the 50 millivolt target, and we are holding relatively steady at about 2 to 3-ish millivolts here. Looks like we have got this board fixed up. So let's go ahead and put this HomePod back together. We'll slap a good subwoofer in there with it for good measure. And of course, good bass. And they'll be ready to rock. Or bump. Or jazz. Or whatever it is you listen to. Let's see here. Yeah, there are a few sins that still can't be saved, unfortunately. Oh yeah, the blinking volume buttons and boot loops. You know, software issues where if Apple just let us click the restore button like they do with all their other devices, we'd have a fix for it. But for whatever reason, the HomePod is special. Despite the fact that these pins give you USB access, and you can just plug this straight into your computer, and Finder recognizes a HomePod is connected. It even gives you a restore button to click on. But alas, Apple doesn't give us access to the IPSW that you already get with all the other devices, so you can't actually restore it. It's dumb. Yeah, well, the strange thing with the watches is there are IPSWs for the watches. So, like, why don't we get them for this, too? There's IPSW restore files for the watches, even though you, as a consumer, can't plug it into your computer. But as, like, a repair tech I didn't, That's like the only thing left that hasn't been repaired, that we haven't figured out a repair for. What's even crazier is the Apple Watches have this like wireless recovery mode now too. They even added support for it in some of the older watches. Alright. New bass speaker. Here we go. This is the right one, right? Let me look real quick. Oh, cool. Very nice. I have one more good bass speaker than I thought. So here's the good one. If we had the right lighting and angle, you could see in there that the voice coil looks really good and nice and vibrant copper color versus the old one that's got just this dingy, charred black look to it. If we push into this one, nice and smooth and quiet, no funky smells. But with their old one, ugh, smells awful, looks awful, feels awful. It's just awful. It's dead. So we're going to take those grommets off and reuse those. Set that dead thing to the side. Pretty much. So I buy broken HomePods off eBay. Based on their description, I can typically expect what I'm getting. Like, if I buy one with no power symptoms or software issues like the blinking volume buttons or boot loops, I can usually count on at least the subwoofer and the amplifier, the power supply, the display, cosmetic parts in general to be still good. Usually I try not to spend more than around $100 to $150 on a broken HomePod for parts. And then if I need to replace parts, you know, if I can't repair it and I have to just outright replace it, let's take for example the subwoofer here. Instead of the normal $60 repair, I just charge an extra $20, so like $80 for the repair. So I already make enough off of the base repair, or I already make enough charging the base repair that I don't need to charge much more to replace OEM parts with other OEM parts as well. I'm not too concerned about, you know, selling the subwoofer if it's the only part I'm going to be able to sell out of the parts pod and making my money back off that. I'll find other, you know, there are plenty other uses for the rest of the parts in a given parts pod that I can find or give out to other people, like screws and grommets and the tweeters and just low demand parts that people generally don't ask for, that I've got more than enough of. But I don't I'm not out to make a huge profit. I'm just out to fix some stuff, discover new issues, and find ways to fix them. Get some traction on the whole right to repair movement, and perhaps finally fix and find a way to fix everything that could go wrong with your HomePod. I love HomePods so much that that's what got me into fixing them, is I wanted to find out every single possible problem with them and how I can fix it so that I can also, you know, not just for myself but for everybody, that so that anybody who really like enjoys the HomePod sound and experience can continue to enjoy that for as long as possible. But if anything got me into this, it was just my pure, like, I love the sound of a bunch of these in a room and throughout my house so much. I wanted to be able to preserve that experience for as long as possible. In my opinion, there's just nothing that does what the HomePod does for its size and its price. Nothing compares to this day. And I wanted to preserve that for as long as possible for me and for everyone else. And I saw, like, the only issue that people knew how to repair when I got into this was the most common no power failure, being that shorted Schottky barrier diode on the amplifier. So once I bought a bunch of broken ones and started noticing that pattern, I started offering no power repairs, and that helped fund buying more broken ones with different issues to dig into those and figure out how to repair the issues that nobody knew how to fix, like death parts and DC offset, no bass, other no power issues that aren't the common typical failure. Yeah. Hope that makes sense and it wasn't just too much rambling there. I also saw just I saw an opportunity here, which was nobody was looking into how to fix these and documenting those repairs. Nobody was out there even offering repair services for these. I was personally pretty surprised. And in the fact that most people still thought that these were impossible to get into, let alone repairable, I thrive on a challenge. And I saw this as one of those unsolved challenges that I could potentially fix. Really good little niche. There are already plenty of other people out there with way more expertise and experience fixing plenty of other electronics, but no one for HomePods. And there were definitely enough people out there with them, with problems. From a news piece. Was it the Podfeet podcast by chance, or the Accidental Tech podcast? Do you know or had someone report the flatulent noise from the subwoofer, and do you know what caused that? So that's what we call death farts. And that is caused by exactly what we just fixed in this HomePod that ultimately killed the subwoofer. So death farts occur when your DC offset grows past somewhere around 3 volts DC. The amplifier notices that and it triggers a forced restart and emits the death fart sound. All caused by those filtering capacitors going out and allowing too much of that DC voltage through the amplifier and into your subwoofer speaker. So that was a really fun one to figure out for the first time. Most of those issues stemming from DC offset, and discovering where the DC offset was coming from was the real breakthrough here. It was in your news feed somewhere. Oh, geez. But basically, long before we knew what was actually causing death farts or excessive DC offset, there was this one guy who thought that it was the actual amp chip for the bass speaker right here that was causing these issues. And at the time, we didn't have any sort of replacement chip for this. We thought it was custom and OEM, and there was no like replacement. So I actually managed to find some from another Redditor's attempt that matched this part, and I replaced it and fixed a few of HomePods that had no bass. The chip here was like blown out. It was obviously damaged. But how we actually discovered the source of the death farts and too much DC offset was I was just Googling around, searching, just doing some basic research to gain a better understanding of how audio amplifiers work, what is DC offset, common sources of it, and I came across a blog post where somebody said DC offset will get worse with heat. And I got to thinking, I wonder if I can take my heat gun and just blast different areas of the board until I see my DC offset spike. And that'll give me an idea generally what area of the board is generating or allowing that DC offset or that DC voltage through. And that's when I found that this general area here, where those filtering capacitors are, was most reactive to that. Obviously, I couldn't, with a heat gun, it's not a very accurate pinpointing tool. So what I did was then, once I knew the general area here to look for, I heated up my plastic tool, and I would go around and I would touch all of these parts until I found that touching my hot plastic tool on these 4 filtering capacitors is what made the DC offset react the most on my multimeter. And so we looked up the spec sheet for this audio amplifier chip, and it just so happens that the manufacturer of this chip, who made a similar version of this chip, also sold an evaluation board with this chip and full specs for a very similar amplifier circuit. So we were able to find that they were most likely using 10 microfarad capacitors in here with a temperature rating of X7R. And I ordered a couple of those for replacements, replaced them, and DC offset be gone. Did some further testing and found that it solved the death farts and loud popping as the HomePod goes in and out of standby mode. The thing is, even if you replace your filtering capacitors, you might still experience a really quiet or subtle pop as the HomePod goes in and out of standby mode still. I can only presume that's some sort of delay in the capacitors actually filtering that DC voltage before it gets amplified and sent to the speaker. Rest assured, and the only thing that really matters is after those first few milliseconds when everything actually turns on and wakes up, do you have a constant DC offset or not? A few hundred millivolts for a few milliseconds isn't gonna hurt anything. But if that's sustained, then that's a sign these caps are going bad, and that can cause damage. So, yeah, bit of a mouthful, but hope that all makes sense. I'm just listening to make sure that that's sealed nice. It wasn't sealing well with that old speaker, but that one sounds nice and sealed. Oh, the Reddit post. Yes. The Reddit post actually came from Podfeet, and they made a blog post on their website, and they're actually going to do a podcast soon, and they're gonna interview me. So keep an eye out for that too. I'm excited. And check out the Podfeet guys. Thank you. And I've still got a lot to learn as far as electronics and what have you. But you die when you stop learning, in my opinion. Get in there, sucker. There we go. All right. I think we're ready for the finishing touches. Roll my sleeves up. Here we go. All right. Oh, and if you guys were curious, before I send all the HomePods back, I go over the mesh one more time with tweezers and rubbing alcohol and make sure it's as clean as I can get it. And I use a microfiber cloth to get the top clean here. You can always just take some rubbing alcohol to cut through all the grease and then dry it off. And you'll get it looking as good as it'll ever look. All right, powering on. Let's see what we've got. Oh, nice. Just got an email from Yang, who had gotten their HomePod fixed by us about 3 months ago, and they were just letting us know that it's still working just fine. So that's always nice to hear from folks, that everything is still good. So, do we got our base?
I'm having trouble connecting to the internet.
Aw, yeah.
I'm having trouble.
And our volume buttons light up nice and evenly. So we've got this one all fixed up and ready to go. How many white HomePods do you get? Good question. I want to say probably every 6 out of 10 are the black ones and every 4 out of 10 are white ones. I feel like I see more black ones than white ones, but I can't say for certain, to be honest with you. Alright, let's set that into its box. Move that over to the side. And break out repair number 3. Ah, this one's got death farts. This will be a fun one. Let's get our text updated on the screen there. Here we go. Do you usually do one per customer, or do you get people sending in pairs? The majority of people only have one to send in for repair. Some people have more than two, and sometimes we get, 2 in for repair at a time. And that's the most that we've ever seen come in from one person. We have had one person that's had like 6 to 8 through us now for repairs. They've bought most of them off eBay and had them drop shipped to us. We've done some color dyeing to theirs and color swaps and what have you. Ah, look at that, another black one. Yeah, I do definitely feel like we get more black ones than white ones. Yeah, and it saves you a little bit on shipping too. So, if you're browsing eBay for broken HomePods to get fixed by me, look for ones that have no power, no bass, or sound issues. Avoid the ones with blinking volume buttons, boot loops, or just clearly just a software issue. All the other issues we can fix. And then during checkout, when you're paying for it, you'll have the option to put in a different shipping address. That's when you'll want to put in my mailing address, and then the eBay seller will ship it directly to me. If you purchase it, use your default shipping address and then message the seller after the fact, more likely than not, they're not going to be able to ship it to a different address than what you purchased it for, because that's outside of eBay's policies and guarantees. And nobody's covered in that case. But when you're going through the checkout process, you will have the option to put in a different shipping address. So if you want it directly shipped to me, make sure you do it at that step and not after you purchase it. And then, of course, I'll ship it straight from my shop to you after we fix it up. So here we've got our power. Let's go ahead and plug this in and power it up. I'm expecting, based on the symptoms being death farts here, I'm expecting, of course, it to power on fine as we see here. I'm expecting to hear the bass work fine still, but when we wake it up, I'm expecting to hear a pretty loud pop, which is indicative of those filtering capacitors not filtering as much DC offset as they should. So let's listen carefully as I wake it up. Yep, that's a pretty decent pop. Not as loud as I've heard on some others, but it's a pretty decent pop. And then again, when we unplug it from power, it's not that loud. So I'm going to go ahead and guess it probably doesn't have too much DC offset on a cold boot, but over time, and I'm sure we'll confirm with our multimeter here, that it starts with a relatively low DC offset, but it'll quickly grow to that 2 to 3 volts threshold and trigger those death farts that we were talking about. Let's find out. If your HomePod is death farting, then you definitely want to unplug it from power and fix it ASAP. Because if you ignore it, you're basically letting your subwoofer cook itself via DC offset death. Too much DC voltage, it'll overheat the subwoofer and roast the voice coil, as we saw in the previous HomePod with no bass. So if your HomePod's death farting or flatulent, you want to get that fixed, at least while your bass speaker is still good. It's a lot easier and more efficient or more cost effective to repair the filtering capacitors than it is to replace the bass speaker once it's gone out as a result of those caps going bad. So if you've got no bass, most likely it's from too much DC offset, which commonly causes death farts too. It's a precursor more often than not. Yeah, thank you for the compliments. I spent a lot of time getting that website working. Fixing various animation bugs that existed even in Apple's original website for that. Oh, that came off beautifully. Better than the last one. There we go. Time for the pry. I think we can pry the rest of that off by hand here. Hey, Epi, how's it going? Glad you could make it. What was it that you're doing near the drawstring cable with the black tape or shielding? I notice on each one you like pressing it back. Yeah, so sometimes when we pry the display out of the frame below it, there's a layer of adhesive on this, and it likes to stick to the display. So I just stick it back down onto the frame, so when we go and put everything back together, it goes back together a little smoothly, a little more smoothly, a little smoother, smooth-like. I could always do it when I go to put the thing back together, but I'm already right up in there. I may as well take care of it right there. Okay. Let's check the condition of our subwoofer here. Feels nice and smooth. Voice coil looks good. And it smells good. So that is a happy little subwoofer. We got to it before it got roasted. So this repair is probably going to go basically the same as the last HomePod that we just fixed for no bass. The only difference, of course, being their bass speaker is still good, so we don't need to replace that. But the death farts come from those filtering capacitors going bad, being so bad, in fact, that they're allowing DC offset in excess of 2 to 3 volts. So we're going to replace the filtering capacitors. We're also going to replace that Schottky barrier diode that we do every time. Prevent that no power issue from happening. Give this board a good look over to make sure there isn't anything else obviously damaged on there. And that should get it taken care of. All right. Board is out. Switch our cameras. And our diode has a date code of 1742K on there. Outside of the usual suspect range, but it will be replaced nonetheless. Everything else looks okay. Nope. So the resistor right here, this is a 10 ohm resistor right next to the subwoofer connector here. Looks like it's fallen perhaps victim to our excess DC offset here. That is destroyed, so we'll get that replaced with a new one. How's the back looking? The back looks pretty good. Alright, before we do any repairs here, let's go ahead and power this up. See what kind of DC offset we're dealing with. Have you ran into any corrosion, i.e. liquid damage in a HomePod? Yes, I have. I have a YouTube short on my channel actually showing highlights of a, couldn't actually tell if it was the big fat capacitor that was bulging in the power supply that had exploded and leaked everywhere, corroding everything, or if it was liquid damage, but there was a hell of a lot of corrosion in that HomePod in our YouTube short there. Never seen anything like it before, and we've We've seen the insides of hundreds of HomePods here. That was actually one that we had bought for ourselves off eBay for parts. Was described as a... let me think. I can't remember if it didn't power on or if it was powering. If it was powering on, I'm impressed, but I don't think it powered on. Definitely a very rare circumstance there. Alright, no changes, no repairs, just powering it on and getting a baseline here. What do we got? Oh, gonna have to jump up to the 2-volt scale. 400 millivolts and quickly growing. Alright, same thing as the last HomePod. Oh, and watch the subwoofer speaker when we unplug this from power. Watch how much it moves. Oof. That's how it dies. The subwoofer's getting that constant DC voltage, which pushes it in or out one way or the other, and it holds it there. And it pushes additional load onto the subwoofer, extra load on the amplifier, makes everything work harder than it needs to, and eventually starts killing stuff. So, game plan here. We're going to replace the filtering capacitors first. That's what's causing that excess DC offset. That's most likely what killed this resistor here, which we will replace next. And then we will replace the Schottky barrier diode to prevent any no power issues, or at least the most common one from occurring. And then we'll give it another test. Up close. Well, let's go. Come on, give it up. All right. Let's get some flux on there. Some low melt solder for our new caps. How's that look? Those are all a little off there. All right. That's looking a little more straight on. Nice quality solid connection on there. So let's move on to this resistor here. We're going to grab our homemade heat shield. Little piece of bent into shape aluminum. I actually cut this out of an iPad mini's display backplate and just bent it into shape. And this fits over my plastic subwoofer connector here in this tall electrolytic capacitor just perfectly, and allows us to blast this roasted resistor here with enough heat to get it off. Wow, that's a lot of flux. That's okay. That thing is baked on there. Give it up. This one's playing hardball. Ha! Wow, that sucker popped right off. Goodness. You cannot defeat me. All right. Let's get that freshened up with some more reasonable solder. Grab a new resistor. That's what it should look like. And that's what the old one looked like. Oh, bollocks. Now let's reposition everything here. There we go. This thing is just sucking up our heat today. We will go at it with our soldering iron. Alright. That'll do. It's not my best work, but it's not going to go anywhere. One thing I just want to confirm real fast is that it is on there. So I'm going to take this parts board here, find out what that resistor has continuity with my parts board. Alright, so the bottom of this resistor should be continuous with the bottom of this cap, and it is. And then the top of this should be with the top of that cap. And we're looking good. Oh, one other part we should replace before we forget, that pesky little diode. Use your iron and apply leaded solder to the pads, then go in with the hot air. Will make your life a lot easier. I used to do that. In just totally my inexperienced opinion, but I found that the solder, or at least tinning the diode, like I do here, generally makes it easy enough for me to not need to tin the pads on the board. And then whenever you go and actually try to tin the pads on the board, I don't know if my iron just doesn't get hot enough or what, but the board seems to pull just so much heat away from my iron that I can't effectively tin the pads on the board, at least for this area, for this diode, without it looking like absolute crap and just having a bad time. Just personal experience. I end up finding more trouble than it's worth for me to tin the pads on the board for this specific diode. Obviously, for the filtering capacitors back here, it seems to work better. The resistor here seems to work better. But the diode, this area loves to suck the heat out of my iron, and it ends up being more difficult for me than it's worth. But it's a good tip. I'm sure I could probably get a better iron or improve my technique somehow that would make that more effective. But can use hot air with iron on stubborn heatsink boards. Yeah. Okay, so is everything cooled down now? It's still a little warm. Let's cool it off real fast. Oh, I see what you're saying. Yeah, I want to get a mount or like a movable arm for my hot air gun so I can position it and hold it, and then have my soldering iron and my tweezers actually in my hands. I'm sure you could do it with holding the soldering iron and the hot air gun at the same time, but I would like to get some sort of swivel arm for my hot air gun to make that a lot easier. So, did we fix this? Let's put it together and power it up. I want to get a hot plate too, or like whatever you're supposed to use to preheat your boards. I'm sure that would would help a lot too. All right. Okay, make sure that's not touching any of that. We don't want that. Okay. Let's power this up. Yeah, as long as your style results in an effective and reliable repair, I could really pretty much care less how you get there. But at the end of the day, what matters is you get a good, solid quality connection that doesn't look like complete garbage and isn't going to pop off or cause any problems a few months down the road. What do we got here? Booyah! We've got hanging out around 1 millivolt of DC offset, a significant improvement from the 500 millivolts and fast growing that we had before. So that should get rid of our death farts, along with that new resistor there and the filtering capacitors. I think that's gotten taken care of. Now we've also got a new Schottky barrier diode over there to prevent the most common no power issue from occurring. Just want to make sure we've actually got base here. Oh yeah, we got the base. It's gonna start blasting, going bwap bwap.
Bad on FaceTime with a history-making year like 2022. What can we expect from you in 2023? What are your goals for next year?
Well, I mean, that's one way to play. That's some music. I don't know what that is. And it won't let me skip. I have no idea what it's playing right now. Alright, I think we got this one all fixed up. Let's get it put back into its shell. Alright, I want to clean up some of the excess flux on the board here, just because it's covering the heat sink here for the amplifier. All right. Nice and clean. Ribbon cable attached. Power supply attached. What do we got? What do we got? Do we got that base though?
I'm having trouble connecting to the internet.
Yes, we do.
I'm having trouble.
No significant popping, and volume buttons light up nice and evenly. So, Epi, we've got your HomePod all fixed up and ready to go. With the death fart ones, more often than not, we leave them plugged into power overnight just to make sure it doesn't, fart on us again. But from our precursory testing here, it appears that it's all happy, healthy, and ready to go. So let's put that away for now. Set it to the side and bring out number 4 from Alex T with no power. Classic. Oh, is it? Yeah, okay. There we go. All right. Oh yeah, Slam, I didn't mean to completely dismiss your advice. It's good advice, and I'm actually it got me thinking about buying an arm for my hot air gun. So we might end up start doing what you suggested. I got to get my hands on the right tools to really do it the way I want, though. So thank you for the suggestion. Much appreciated. The right tools always make the job much easier. Let's see here. A beautiful white HomePod. Get that power cable out of here. We don't need you. All right. Let's see what's going on with this white HomePod here. Giving it some power. No signs of life. 6 watts of power draw at the wall. Most likely the classic case of a shorted diode on the amplifier. Based on that power draw there. Let's crack it open and find out. Here we go. Oh, this one's not going to be a fun one. It's going to be icky sticky. Oh, all right. I am proven wrong. That's not too bad. What's your typical repair fee on these? So pretty much anything that's a repairable issue, I usually charge $60. So that's no power, death farts, sound issues or no sound. Most of those issues end up being $60. The only time I increase the cost of repairs is if the bass speaker needs to be replaced. In that case, I charge an extra $20, so $80. And then you've got return shipping too. So however much that is based on how fast you want it, which carrier you want to use. All right, it's time for the pry. Oh, this one's not playing nice. Oh, maybe I spoke too soon. Yeah. Yeah. Give up the beans. Goodness. There we go. Give it up. Ah. Yeah. Alright, woofer check. Voice coil looks to be in good condition. Feels nice and smooth. Smells fantastic. So that is a happy little subwoofer. Always sniff your subs. The good subwoofer smells uniquely like the inside of a HomePod. No, I'm just kidding. It's got kind of a like a fresh, almost like a fresh. Man, it's hard to describe. You're just gonna have to smell one yourself to understand. Here we go. Quick visual inspection. Diode has a date code of 1748K. It's almost certainly the culprit. Everything else looks good on the board. So let's go ahead and test that diode, confirm that it is, as we suspect, shorting out. Yes, indeed. That diode is shorted. Let's get it replaced with a new one. we go. Brand spanking new diode. That's a lot of flex. There we go. All right. Let's cool this off real fast. That should do it. Here we go. Very nice. We got power. Do we got any DC offset dough? Nah, DC offset's looking pretty chill at around 1 to 2 millivolts. Perfectly acceptable. All right. Let's get this put back together. No power and death fart repairs have always been a grand slam win. Wasn't always like that. We'd come across the occasional no power issue that stumped us, but we found where the logic board commonly has its shorts and threw some info up on our website for you guys. Most often though, the no power is coming from your diode shorting out, but on rare occasion, it comes from a shorted cap on the logic board. I'd say like probably 1 out of every 20 no power repairs end up being something other than the shorted diode. Why is DC offset important? So I'll try to explain as best as I can. You might be better off finding your answer on Google, but I will say, DC offset is pretty much just how much DC you have away from zero, or how far off of 0 volts DC you are. That's what DC offset is. So when I say we've got 50 millivolts of DC offset or 500 millivolts of DC offset, I'm just simply saying it's got 50 millivolts or 500 millivolts of DC voltage showing up on the subwoofer. Audio, analog audio, is an AC signal. You don't want your speakers getting DC voltage. It's essentially the same thing as taking a DC battery and sticking it onto your speaker. Watch what happens when we stick this 9-volt DC battery under our subwoofer. You hear the pop and you see the speaker move, but it's not moving both directions, it's moving into one direction and staying there. What this does is this puts extra load on your voice coil, and it will overheat it over time and just totally roast it. The reason why AC in your audio signal doesn't kill your subwoofer is because AC, your audio signal, is moving the speaker back and forth equally. It's passively cooling that voice coil. Whereas with your DC voltage, you're pushing the speaker one way or the other and overheating it. So DC offset is an unwanted side effect. It's pretty much inherent with any audio amplifier that amplifies an analog audio signal. But what you're supposed to do is filter that unwanted DC offset and bring it as close to 0 as possible. That's not really possible in the real world. Electronics aren't perfect. Things are built to a certain tolerance. But ideally, you want your DC offset to be no more than 50 millivolts. That's generally what's acceptable in the audio industry, I guess you could say. 50 millivolts won't hurt much, but it will start to affect your sound a little bit. You might notice a bit of a pop. But it's once you start reaching like hundreds of millivolts or beyond that you start to really cause damage to things. Hope that answers your question. So the filtering capacitors are supposed to remove pretty much all of that DC voltage and bring that offset to 0. As those filtering capacitors get worse over time, not even necessarily as they get worse per se, it's just an inherent property of MLCC capacitors, like the ones they use here. Over time, they'll just naturally lose their effectiveness at filtering DC voltage. So another thing is that I mentioned earlier, heat. The hotter your capacitors are, the also less effective they become at filtering DC voltage. But yeah, in short, bad caps will allow DC voltage through the amplifier, thus resulting in your DC offset on your subwoofer. What actually happens is the logic board sends its digital audio signal to your amplifier, and then there's a digital to audio converter chip that converts that digital audio to analog audio. But that analog audio straight from the DAC by itself isn't strong enough to power your speakers. So that weak analog audio signal is passed through your filtering capacitors and then to your main amplifier chip, which is what takes that weak analog audio and beefs it up to an actual audible signal in your speakers. So what happens is, like I said, in between your digital audio converter and your audio amplifier, your filtering capacitors are supposed to stop unwanted DC coming from your DAC circuit and going into your amplifier circuit. At the end of the day, the amp's job is simply to amplify whatever you give it. So if you give it AC signal, it's going to amplify that AC. If you also give it DC, then it's going to amplify that DC. So when those caps go bad, they right there may only be allowing a few millivolts of DC offset, but that can easily get amplified by your amplifier into a bigger problem, a larger DC offset, which of course puts extra load on your amp. Unwanted DC voltage on your speaker will fry that, so on and so forth. So would you expect the same DC offset issues to occur again in a number of years as the capacitors continue to wear? Yes. There is a formula to calculate roughly the expected lifespan of your capacitors and how much DC voltage they will filter as they age. I haven't actually quite wrapped my head around how to use that information that they've provided. What I can basically gather is replacing the filtering capacitors should last at least a few more years, if not longer. But it is an unfortunate inherent just property of those capacitors is eventually they will lose their effectiveness and more DC will be allowed to make its way through. So I use this screwdriver because it can reach these bits better, or these screws better, and I have less risk of, with the power tool here, stepping off somewhere and breaking off one of these tall capacitors here. It's also a little bit on the thicker side, so this just fits better inside of here. Jim sent us an extension bit, so hopefully in the next few days here that'll actually show up and we'll be able to fit this better in here and start using this inside too. Also, my primary gripe is I cannot for the life of me get these bits to magnetize. And funny enough, even if I take my iFixit bit, which works just fine, and I put that onto here, nothing. So, and I've tried to magnetize these bits, and it ain't happening. So trying to fish the screw with one hand with the screwdriver in the other in there can be a bit of a pain. More of a hassle than it's worth. So I usually keep this to the screws on the outside, at least until I can get a magnetized bit, or that extension that Jim got us. If I can magnetize that, that'll be great. Yeah, it must be that the magnet in the iFixit one in here is a lot stronger. I've been meaning to find a stronger magnet to stuff in there to see if that'll do the trick too. Oh, battery died. This is one of my favorite features of this screwdriver though. It'll let you use it while you're plugging it in, or while you've got it plugged in charging. And I've got the second one on standby there in case this does not like it. Yeah, let's get the standby one out. Nope, goodbye. Here we go. This one's almost dead too. Oh, I'm bad. It's okay, it should last us through the rest of this one and the next one. Pretty good battery life though. I didn't charge it yesterday and it had 3/4 battery life. And it made it through most of today too. Yeah, no, I'm entirely self-taught. I dropped out of high school junior year and got a GED. Haven't taken any formal education beyond that. I've been at a software company for the past 10 years, various roles there. Currently a sales engineer, so I get a pretty decent taste of a whole wide range of issues to work on. But yeah, I'm all self-taught. If you can find it, if you can teach it yourself online, I'll do it. And that's how I've learned pretty much everything I know, is just basically knowing how to search for something on Google and just trying things out for myself. Doesn't go without saying, I would love to go to college, get some proper formal education, because my wife has been my wife's gone through college, and man, she is, you can tell talking to her, or anytime you get in a debate with her, she outsmarts me by far. Oh yeah, you bet many HomePods sacrificed in the early days. This was the first board that I had ever tested with, and ultimately what I decided with it was to start depopulating the entire board in an attempt to try to, reverse engineer it. But it's also proven to be a useful tool to find what components have continuity with what else, or which pads have continuity between each other, in the event a board-only repair comes in from somebody who completely botched their own repairs and damaged pads. And it's a good reference board to check which things should be connected to what and what workarounds we can come up with in case somebody incurred a bit of damage. Yeah, let's see, this was my first one. And then I've got all those. I'd say all but 2 of those are from my personal experiments, trying to figure out the various issues, possible ways to repair those issues. I was basically flying blind, trying to figure half of these issues out. There's no schematics, no documentation or information available online. It's just probe, replace a part, see if it changes anything, try and try again. Sometimes I broke stuff, sometimes it ended up working, and then I would try to find more broken HomePods with the same issue to confirm that that repair actually worked. And then after, I want to say a few dozen of those, I built up the confidence to start putting my name out there and offering this as a repair service for other people. And basically, when I first started out, I was actually giving repairs out for free. If people paid for shipping both ways, I would just fix it for free, just to get more experience, get the hang of it. And in the off chance I made any mistakes, like I broke something or what have you, or maybe I made a mistake and they have to send it back again, people would be a little more understanding or willing to work with me so long as I'm giving you free repairs. Once I felt like I was getting really good at it, then I started charging people for repairs. And of course, as more business comes in, we only had 1 or 2 show up every few days at the start, and now we've got on average 3 to 5 showing up a day. I also had to make sure that I had plenty of parts stocked up before I started offering it for others, because at the start, man, I was really beating these things up trying to get them open, because I would scratch them or crack them, or more often than not some sort of damage to them, so I'd have to have like a stock on hand basically to swap them out if I messed it up. But we got practice makes perfect. You can watch all the videos and do all the Googling that you can bear in the world, but you got to get some practice and real world experience, at least to complement it. I'm not going to go out and say, be one of those people that's like, oh, 8 years of job experience is better than 8 years in college to get a degree. And it's like, they both bring a lot to the table, and they can both complement each other. Get that formal education and then apply it and practice in the real world. Because I may seem slightly intelligent, but I'm sure I'd be a lot farther with some real classic education. Of course I make it look easy. We've been through, probably around 300 of these by now. I need to update the number on the website again. I am willing to place the bet, make the claim, and say, I've probably fixed more HomePods than anybody else in the world. I've said it before too, my tombstone, I want to be in the shape of a HomePod. And I wanted to say, here lies the guy that fixed HomePods. I wouldn't mind being remembered for that. Sad. There we go. That's true. That's true. That's a good point. But I also feel like I do lack in some basic skills still. And it does show a lot whenever I talk to my wife. But you're right. Yeah, I wouldn't be as far as I've gotten now if I was if my brain was smooth. Sometimes I feel like it is though. Yeah, get in there. Oh, this rocks. My hands would be dead from this. That's what life's about, man. Finding ways to improve things, make things better. Make life better for, you know, the next generation. Sure, have some fun while you're doing it. But, yeah, I totally agree. Yeah, I'll never forget that original teardown. Ah, it's so painful. Like, I mean, to be fair, they were one of the first to crack into one, so... You gotta find out a way until you know a better way. You sometimes just gotta make your own way until you find it. Well, so, and what's strange is, where's a basket to show you guys? If you look at the bottom here, there's like room and like slots in here where it looks like they would have a tool purpose built to like reach in here and just pull the basket right off without any hassle. So like Apple designed it with a bit of, I wouldn't say repairability per se, but they designed it with a little bit of, you know, someone's going to have to take this apart in mind.
in there.
There we go. Look, there it is again. Look at this fat freaking dent in the display here. And this was not us. I can tell you because, and you can go back and watch the replay if you don't believe me, but we only insert this tool like a centimeter in at most. There is no way, even if we got this tool all the way in there, it just doesn't reach that far. And then of course when we're using this, we're going like a few millimeters in there. I see these displays dented up so often. I can only assume there's nowhere here for it to get dented from either. It's not like it's getting smashed in from the top after it was put together. They must have put this together like this. And I see this so much. I've got a stack of displays over there and like half of them have the same thing. I don't get it. The quality control, man. I understand, like, this probably doesn't affect anything. But I mean, if they're letting stuff like that slide, what else are they going to let slide? I just want to know how. No previous repair attempts on most of the ones that we have come in. It's pretty easy to tell if they have. Unless, highly doubtful, but unless Apple themselves have taken it apart and then glued it back together with all the right adhesives. But as far as we all know, Apple does not repair any of these. They're all from the same original manufacturing run. And when you send a broken one into Apple, it gets sent to Daisy to be dismantled into its raw recyclable materials. A sad fate that I intend to save every HomePod from. All my homies hate Daisy. The shipping costs you have on the web, are they internal US? Yeah, so pretty much shipping between UPS or USPS for a roughly HomePod sized package and HomePod weighted package anywhere in the US has costed as much as about $25 to $26. And that includes $300 of insurance. It would be a couple bucks cheaper without the insurance, but I always opt in for it and I make people pay for it. But it's like $2 or $3 extra. Nice little bit of insurance to have in case someone steals it or drops it on the way to you. Haven't needed to use it yet, but yeah, those are the costs, shipping costs for within the U.S. If you are a U.S. citizen, check out Pirate Ship because I've saved an insane amount of money using that instead of going directly to UPS or USPS's website. Ooh, shipping from Oz. Very nice. Let me check and see how much shipping from the last... Because I think we've had a few repairs from there before. I might have how much it cost. Filter from country. Oh man, both of them were just the amplifier boards, so I don't have an accurate idea how much it would be to ship a whole HomePod there. Oh, you know what? Maybe, hold on. If you've got a zip code to give me, I can get a quick quote. Let's see here. Oh, like seriously, like $70? $70 for the cheapest UPS tier. $95 for the cheapest USPS tier. That sucks. Oh no, you're fine, man. We've got all the time in the world to dick around here. All right. Yeah, that's freedom dollars. And that's just from me back to you. All right, let's see if we've got power. Ooh, yeah, of course we do. Some people have forwarding services too. I don't know if you have or know of any mail forwarding services that can take it from the US to where you're at. But those can sometimes end up being a little cheaper. What do we got?
I'm having trouble connecting to the internet.
I'm sure you are. All right, everything checks out on this one. Let's put it to the side. And get our final HomePod for repair out. Trying to hide the personal information. Here we go. Oh, you threw me in for a loop there. White HomePod in a black box. Set all that to the side. I'm trying to make room. Okay. Get our text updated on the screen here. Our final pod for repair today, coming to us from Michael with Death Farts. Let's see. I might wait a little bit until my popping HomePod gets a bit worse. That is a good game plan. Here's my general rule of thumb for folks asking about, my HomePod pops. Should I get it repaired? I generally tell people if the only problem you have is that it pops as it goes in and out of standby mode every 10 minutes or when you wake it up, if that's your only issue, I wouldn't worry about it. If, however, the popping sound isn't, it's really loud, it's a constant popping sound, and or you've got bass issues like death farts, that's the point where your DC offset is starting to grow to the point where it's it can cause damage and issues. And that's when I would unplug it from power and get it repaired. But if all it does is the quiet, subtle popping sound going in and out of standby or when you wake it up, that's totally fine. I mean, that's pretty much expected behavior from even a totally functional working HomePod or a HomePod that's just had its filtering capacitors replaced. Totally fine. So a death fart is, let me see here. I was thinking about pulling up a video of us doing a previous death fart demonstration, but I'll just talk about it real quick. A death fart is basically like that bass drop sound that you hear, and it followed by an unexpected restart. Sounds like it's like dropping to bass, like really loud bass drop. And then you like try to tap on it, and it's like rebooting itself right after the death fart. A death fart occurs when the DC offset grows past like 2 to 3 volts, and the amplifier detects that extra DC voltage. It'll force an unexpected restart and play that death fart tone. So I'm gonna plug this into power, and you guys take a quick 30-second break, grab a drink, grab a bathroom, and we'll be right back. I'm gonna plug this into power while we do this. And we are back. So, what do we got?
I'm having trouble.
That's a pop. Oh boy. Okay, so I'm gonna go ahead and hazard a guess that we've got the same issue as the previous death fart repair that we just fixed up. The filtering capacitors are probably going bad, allowing too much DC voltage through the amp into the speaker, growing past 2 to 3 volts, which forces an unexpected restart and plays the death fart sound. Let's take this apart and get the amplifier board onto our bench here and power that up, connected to our multimeter, so we can confirm that's what's going on here. And while we've got it apart with the bad parts on it, we'll go ahead and hit it with a little bit of heat. I'll show you guys exactly how I discovered which parts were causing this issue and how to repair it, and you'll get to hear and see a death fart live. So, same as always, let's crack it open. Hello? Great red rock band name. That's hilarious. There we go. Oh, it looks like they're mesh is a little worn on the top. Didn't notice that until I got this off because it covers up a little bit of it. So we'll just want to be careful with that. And it doesn't look bad. You can't even tell by looking at it unless you really know what to look for. Are you using specific tool to open these? So this is my preferred tool to pry this top plastic off. And I keep saying pry, but we're not using this to actually do any prying on this piece. We're actually just going around a few laps to cut the adhesive until this pretty much just pops off on its own. But this is my preferred tool for it because it's got the nice handle and the indents for me to hold it just like this and cut through that adhesive effectively. It's strong enough to not flex, but also because it's metal, you run the risk of like scratching this up and potentially cracking it. If you're just starting out, I would suggest maybe floss or fishing line. You can use that to pull it through and cut through the adhesive, or you could use a plastic credit card. But I you know, once you get the hang of it, this is the tool to use for it, just because of the ergonomics of it. This is the iFixit Spudger, and then this is what I use in combination with this to pry this plastic and PCB display up. So once we get the screws out, I'll show that. So we take our metal tool to give us a gap, and we're putting that under both layers of this display here. Let me show you what I mean here. So here's the frame that the display sits on, and when we pry this out of the frame, right? We don't want to pry the frame out. That's no. The frame is screwed in still. We're prying this display out. And when you're prying this out, you want to make sure you're prying this assembly with this plastic top and the PCB that it's stuck to. You don't want to get your tool in between the plastic and the PCB itself and pry like that, because you run the risk of scratching up your PCB and damaging traces and destroying your display. Also, you run the risk of breaking off your ambient light sensor in there. Right there, teeny tiny little guy. So that's how we do it. We give ourselves a gap with the metal tool to insert the plastic one, pull the metal one out, and then we can push this around the display to pop that off. And sometimes the adhesive underneath will fight with you, but sometimes it'll just pop off nice and clean like this. You get lucky. Just if you lose some of your adhesive on here, it unsticks. Just stick back as much as you still got back down. It'll be okay. Oh, I did it again. Here we go. Gonna try to cruise through this last repair here so we can wrap up the day as soon as possible. Get the emails sent out for people's repaired HomePods and get some dinner started. Every time I look at my inbox, there's another email. Since we've started repairs, I've gotten like 11 more emails. I would not be opposed to having competition in America for HomePod repairs. Please, if you fix HomePods and you're in the US, let me know, and I will more than gladly put your info up on my website as a, under the list of people who do repairs. Competition is good. And, well, if things continue, I don't know how busy things can get, but it has the potential to become more than I can handle. Oh, that's like the best way to get your hands on many HomePods. That's another reason why I got into repairing them, is I wanted to figure out how to fix them so I could buy broken ones on the cheap and build out my collection of them. And boy, for how much it would cost you to ship your HomePod to me, you could get a hot air rework station. Actually, based on the advice you were giving me, it kind of sounds like you've got most of the tools you would need to do micro soldering. But I mean, typically, for the cost of shipping, you can get the tools you need to do to fix them yourself, build out your collection. Time for the woofer check. Looks good. Feels good. Smells good. Happy woofer. How are replacement parts obtainability? So the most common issue, no power, just needs the diode replaced. It's a 60 volt 5 amp Schottky barrier diode, generally quite widely and readily available. I've got, obviously, I'm sure you've seen it, but I've got the part number, if you're curious, the exact one that I use, and specs for it up on my website. But that'll take care of most of your no power issues. The capacitors, again, pretty much the same thing. It's a fairly standard part, pretty widely available. The 10 ohm resistor that sometimes blows up that you saw us replace on Epi's HomePod, that's a pretty widely available part. But as far as like actual HomePod components, say the subwoofer or a plastic top or the mesh, pretty much impossible to find specific individual parts. In that case, your best bet is to go onto some classifieds or like eBay or Craigslist or Facebook Marketplace or something, and find and buy broken HomePods. That way, you've got not just the part that you would need, but pretty much a full set of parts for more repairs and testing for you to do. But yeah, the board, like the actual components that we usually replace, those are almost always pretty easily available. What are we doing here? We're taking this one apart. I'm flattered that you think my channel is worth the spam, but get out of here with your spam. They're taking over. Ba-da-dum-bum, ba-da-dum-bum, ba-da-dum-bum. They're taking over. Here we go. Oh, give me 15 seconds. I'll be right back. Okay. What was this one? Death farts? Okay, let's power this up. That's right, we were going to do a live death fart demonstration. Give you guys a little treat to wrap up the repair stream for today. A little DC offset is okay as a snack. What, in your opinion, is justified cost for parts of repair HomePods? See one for $100. Yeah, I generally pay around $100 for a broken HomePod. I've paid as little as like $50, $60 for one, and as much as like $150 for one, depending on what issues it has and its overall condition. But $100 is pretty much, in my opinion, the average. And in my opinion, a decent price. Depending on what's wrong with it. If it's an easy thing to fix, then easy and cheap thing to fix, then I mean, you've essentially got yourself a $100 HomePod with just a little bit of your time and effort. Good deal in my opinion. So here's what we're gonna do. I'm gonna turn my heat down to like 300 here. And we're gonna wake this up. Look at that DC offset. Oh my goodness, 550 millivolts and quickly growing. Watch what happens when I heat those capacitors up. Watch the DC offset. Watch how much the subwoofer moves too, because it's gonna dance around quite a bit when we do this. See that? Yeah, that's a death fart. Yeah, it's interesting that the amplifier has a component or something built into it to detect when there's too much DC offset and do this sort of death fart forced restart behavior. I'm quite fascinated by it. Do you have time to demonstrate how you measure that? Could you elaborate on what you are taught? What I'm measuring? What exactly? Sorry, I'm a little slow. Yeah, so measuring DC offset's pretty simple. I've just got my multimeter connected to the subwoofer here, and I'm actually cheating a little bit. I've got these alligator clips soldered into my subwoofer. But if you're doing this on your own, most likely you're not going to do this to your subwoofer. So you can just take your positive and negative probe and put it right onto your positive and negative speaker wires on the side of the woofer here. Of course you want your subwoofer plugged into your amplifier when you do it, but you set your multimeter into DC voltage mode and go ahead and connect your multimeter to your subwoofer, get your amplifier powered on, and after it finishes powering on, go ahead and wake it up, get it out of that low power standby mode, and you can take your DC offset measurement. And like I said earlier, DC offset is just simply how far away from 0 volts you are. So it doesn't matter if it's showing positive or negative, you're just looking at the absolute value of that DC voltage. So anything below 50 millivolts is considered safe and fine. Anything above 50 millivolts is usually when I considered replacing these filtering capacitors. You typically start to see components getting damaged, including the subwoofer speaker, once you're hitting past like 300 millivolts. And okay, that's what you were curious about, is how I connected it. Yeah, it makes it a little quicker and more efficient for us. You know, instead of sitting there holding the probes on it and trying to dance with everything. So. Oh, that's hilarious. That's good. Do you see it? This capacitor is not, both of these aren't lined up right. They're like crooked. That's worse than anything I've ever done. That's great. Good quality control, guys. Everything else looks good though. So let's replace our filtering capacitors. And then, like we always do, we're going to replace our Schottky barrier diode right here, just as sort of preventative maintenance. Hopefully avoid that most common no power issue. There we go. Some low melt solder to make these replacement caps still go on nice and smooth. Nope, almost forgot to turn my heat down. We don't want to cook our brand new caps if we don't have to. Yeah. Have you considered a quick? I think you would be happy. What is a quick? No, I do not recognize that term. What you talking about? Ooh, hot air station. Let me look it up. As soon as I get this diode pulled off. Let's see, quick 861DW. 1,000 watts, oh boy. $300, oh boy. Oh man, but I bet it's the bee's knees though. I don't know if I can run 1,000 watts because 90% of the outlets in my house are on the same single 15 amp circuit breaker. It sucks. But hopefully within the next year, we will be buying our own house. And better believe each freaking outlet's gonna get its own 20 amp breaker, damn it. And each room will have its own 220 volt hookup too. Because why not? More power. Dude, it's literally twice as much as 110 volt. Freaking nerds across the pond with their 220 volt AC home outlets. They can boil their water almost twice as fast as we can. That makes me jealous. Yeah, 240 volt, I'm mad jelly. Give me that. What's dumb is, I'm sure you guys have watched the Technology Connections video and a handful of other videos on it, but like American households generally get 220 to 240 volts in, and then they branch it off to 120 volts throughout the house. So like, we could have 220 volts everywhere, but we chose not to. We choose not to still. Alright. Got everything we wanted to replace done here. Let's cool this board off real fast before we do any testing. Where's my mouse? There it is. Found it. Okay. Power supply. Let's put a couple screws in that so it doesn't pop out. I know, Peabody. Cats are getting hungry. It's past their dinner time. logic board, subwoofer. The HomePods are multi-voltage. Internally speaking, every single HomePod is identical. The only difference is the physical connector on the other end of your power cable. Everything else is identical. The power supply is auto switching. It'll support 110 through 240 volts AC. The wiring for each plug is identical too. Every single power cable, regardless of where it came from, only has the live and neutral. It has no ground, and there is no ground wiring into the power supply either, regardless of which power cable you're using or what voltage it's rated for. But they're all the exact same, internally speaking. So yeah, we get people shipping their HomePods from across the world with 240 volt power plugs, but we tell them don't even bother including it. If they do, we just yank it, and as we do with all of them, we use our power cable for testing, and they all work the same. All right. Well, speaking of which, let's get this one powered on and see if we've got any DC offset still. I think we all know what to expect. I mean, that's those caps. It's their job to remove that DC offset, and if you've still got offset, then you something up with your caps. Maybe you didn't put them on right. Maybe you overheated them and killed them. Maybe you don't have a quality connection. Maybe you've got a little short. Let's see what this one does. Very nice. So we're sitting at around 6 millivolts of DC offset, and we're holding relatively steady. So this one is fixed. We can put it back together and be done for the day. Do these have a transformer on board? AC to DC. I think that's what this is your transformer. If it's not that, then it might be this, but I think it's that. Get the shell. Drop that amp in. Oh, you get back here. Hey, thanks for the compliments and thanks for the sub, man. I love chatting with you guys and answering any questions you have. And potentially getting more people involved in repairs. Maybe not for, as a service, but even if it gets one person to buy their own broken HomePod and fix it and experience that, that's all worth it to me. Man, I remember when I fixed my first HomePod for myself. I was so excited. It's such a great feeling. Every single time I get one of these working again, it's such a good feeling. Like one tiny little part, and we saved it from going to the dump because of it. And I truly understand how much people enjoy these things, how much they love them. I've got 10 of them in my office room alone. And it's an experience. You feel the bass in the floor and the walls in your chest. You feel the staging, like I'm horrible at these terms. You feel like how wide the stage feels, and you can feel like the different layers in the instruments. Sure, yeah, you could go spend hundreds or thousands of dollars on regular speakers and an audio amplifier, but for $300, we're talking retail price, for $300 to $350, just nothing beats the performance and the size and just what these can do. Ah, man. I've been addicted ever since I bought my first HomePod for myself back at the end of 2018. I'm telling you, dude. Fucking, excuse my language. $50 to $120 per broken HomePod. 30 minutes to an hour of your time once you get proficient at it. One of the cheapest and easiest tickets you can get into a whole home audio experience, and a damn good one at it. You cannot beat it. Can you sync these to all play together surrounding a room? Yeah, you can AirPlay to as many AirPlay 2 capable speakers as you want. I've played up to, I think, like 35 AirPlay 2 devices at the same time. I was messing around with some of the old Airport Express Gen 2s. These also are AirPlay 2 capable, so you can connect in optical or analog audio speaker to it, and AirPlay to your Airport Express the same as all your HomePods. So if you've got a big beefy subwoofer that you want to add to your HomePod setup, you can hook it up to one of these. Bada bing, bada boom. You're ready to bump. It will not do like multi-channel surround sound. It will do stereo, so assuming you've got the stereo pair set up and you AirPlay to multiple stereo pairs, each stereo pair will do their left and right respective channels. But that's as far as it goes. It doesn't go actual like multi-channel surround sound. Interesting. Yeah, do that, or I've got a YouTube short on my channel doing this, but you can take your Airport Express 2 apart. Inside of it, it's got its internal power supply that takes the AC input and converts it to, I think it's like 3 or 5 volts DC, and the original Apple Hi-Fi speaker. Gosh, if you guys remember that. Its power supply also happens to have the same DC voltage that the Airport needs. So you can crack one of these open, take the raw Airport Express board out, wire it into the power supply for your Airport or your Apple Hi-Fi, and you've just given your Apple Hi-Fi AirPlay 2 support. Fun stuff. All right, these screws are playing around. They're trying to give me a hard time for the last repair for the day. I don't play nice. Yeah, I've got to make a proper how-to video on how I did that. I've got a lot of people asking how. And the short video just doesn't cut it. It gets the idea across, and anybody who's got the initiative can get it done with the info, or just by themselves poking around. But you know how people are. You gotta break it down. let's see what we've got here. Drum roll, please. Do we got good sound?
I'm having trouble connecting to the internet.
No popping. Well, no significant popping. If it's there, I can't hear it.
I'm having trouble.
And volume buttons look nice and even. So folks, we got everything we needed to fixed up today. 5 out of 5 successful repairs. Quite a busy one. Oof. And we're running 4 hours and 30 minutes in. So not too bad, not too bad. Not my fastest, but not my slowest. Well, if you guys have any questions about any of the repairs that we've done here today, or HomePod repairs in general, feel free to leave a comment down below. I always suggest folks first check out the website, nixfix.com, at the bottom right there, and head over to the common issues section if you're trying to figure out more information on how to fix your own. I've got all the common issues that we've fixed here on the channel, steps to diagnose and repair that issue, and part numbers and specs where available for those parts that you may need. I've also got my contact info up on my website if instead of trying it yourself, you'd rather just mail it in for repair to be here on the channel. If you feel somewhat confident in taking your own apart, but you don't know about doing the board repairs, I do offer a discount if you send just the board that needs repaired in. Well, folks, that's about it. Hope you all enjoyed, and I'll catch you in the next one. Thank you guys for watching and chatting with me too. It's been a good one. Goodbye!